Welcome back, everyone, to another deep dive.
From AI-inspired insights from farmers.
If you're enjoying what we're doing here, we'd love to hear from you too.
Absolutely.
Hit that like button, subscribe to the channel, and definitely leave a comment telling us what you want to see more of on this deep dive.
We're always looking for new ideas, and we really value your feedback.
So what farm-related mysteries are you dying to uncover?
Right.
What questions are keeping you up at night? Let us know, and maybe we'll tackle them in a future deep dive. Welcome to this deep dive. Today we're looking at a building material that's really making waves, especially if you're exploring new directions in farming or sustainable practices.
That's right. We're talking about hempcrete.
Exactly.
Yeah.
Hempcrete. Derived from industrial hemp, it seems like a really interesting possibility for construction, maybe even a value add for farming ventures you might be considering.
Mm-hmm.
Our aim today is to really get to grips with what hempcrete is all about, its potential, its relevance, especially if you're starting out or diversifying.
And we'll cover quite a bit. We're going to look at its environmental credentials. We're calling it eco-warrior insulation.
Nice.
We'll examine its strength, its durability, try to demystify the actual construction process.
Yeah, the practical side.
The costs and scalability, always important, and check out some of the global pioneers making it happen.
And stick around because we've got a bonus insight for you later, how to actually find workshops and certified contractors if you want to take this further. Okay, let's start with this eco-warrior insulation idea. Can you break down what hempcrete actually is and why it's getting this eco-friendly reputation?
Sure. So hempcrete is basically a biocomposite material. It's made mainly from hemp stalk hurds, that's the woody inner core of the plant,
Okay.
mixed with a lime-based binder and water. The big environmental plus is its carbon sequestration capability.
Right, it pulls carbon out of the air.
Exactly. As the hemp plant grows, it absorbs a significant amount of CO2. That carbon gets locked into the hemp hurds and then into the hempcrete itself.
So it actually stores carbon.
It does. It effectively offsets the emissions from its own production. We're talking about roughly 72 kilograms of CO2 absorbed per square meter of hempcrete.
Wow, so it's actually carbon negative.
That's the term, yes, carbon negative, which is, a huge contrast to conventional concrete, which is a major source of global CO2 emissions.
That is a massive difference. And this isn't just theory, right? It's actually being recognized in building codes now.
Yes, that's a key development, especially in the U.S. Hempcrete used as a non-structural wall infill system, think similar to cob or straw bale.
Okay.
Well, it's been approved in the 2024 International Residential Code, the IRC.
And that covers most states.
49 out of 50 states for residential building, so for new houses, townhouses. This approval makes using hempcrete much more straightforward legally.
That's a big step for adoption. So it's green, it's recognized. How does it actually perform as insulation? That eco-warrior tag suggests it's pretty good.
It really is. Beyond the carbon aspect, it has some great properties. It's fire resistant, which is obviously important for safety.
Crucial.
And it acts as a natural humidity regulator inside a building. It absorbs moisture from the air when humidity is high.
Like a sponge.
Sort of, yeah. And then releases it back when the air gets drier. This helps create a really healthy indoor environment.
How so?
Well, because it does this naturally, you don't need extra chemical treatments. It's non-toxic, biodegradable, naturally antifungal, and even deters pests.
That sounds much better than some traditional insulations that can off-gas, questionable chemicals.
Exactly. And on top of that, its thermal insulation performance is excellent.
So it keeps the heat in or out?
Both. It manages temperature swings really well. That means significant energy savings because you need less heating in winter and less cooling in summer.
Makes sense.
It can even absorb up to 20% of its own weight in water without losing its insulating value. Plus, it's vapor permeable. It lets the building breathe.
Breathing walls. I like the sound of that. And you mentioned it has high heat storage.
Right, thermal inertia. It has a relatively high capacity to absorb and store heat, which helps keep indoor temperatures stable even when the outside temperature is fluctuating wildly.
You also called it better than zero carbon. What's the distinction there?
Right, so carbon negative means it absorbs more CO2 than emitted during production. Better than zero emphasizes that this benefit extends across its entire life cycle.
Oh.
And there's another factor. The lime binder actually continues to absorb CO2 from the atmosphere over time as it cures and hardens through calcification.
So it keeps on working even after it's built.
In a way, yes. Compare that to conventional concrete, responsible for maybe 8% of global CO2 emissions and a huge water user. Hempcrete uses much less water in its processing, too.
The environmental case seems really strong. Okay, let's shift gears to strength and durability. The word hemp might not immediately scream strong building material to everyone.
That's a fair point, a common perception. Now, hempcrete doesn't have the same compressive strength as traditional concrete. It's much lower, about 1/20th, maybe 1 megapascal.
Okay, so what does that mean in practice?
It means you wouldn't use it for, say, foundations, especially in earthquake zones, or for the main load-bearing pillars or beams of a building.
Right.
But it is strong and durable for what it's designed for. And interestingly, its strength and other features actually tend to increase over decades as it fully cures and petrifies.
So it gets better with age.
In a sense, yes. The way you manage the lower compressive strength is by using it with a standard structural frame, typically timber or steel.
Ah, so the frame takes the load.
Exactly. The hempcrete acts as the infill, the insulation, or a sort of insulating veneer around the frame. It's non-structural in that context.
And does being non-structural offer any advantages?
It certainly can. Because it's not carrying the primary load, it often doesn't need the same level of intensive structural approvals.
Which could save time and money.
Potentially, yes. Less testing, fewer certification costs, fewer delays. And despite the lower compressive strength, it's quite resilient. It resists cracking well.
So maybe even good in those seismic areas, just not for the main structure.
For non-load-bearing applications, its ability to flex slightly without catastrophic cracking could actually be an advantage in seismically active areas.
Interesting. And putting it around a timber frame, does that help the wood?
It does. Encasing the timber or steel frame members in hempcrete offers protection. It helps shield the wood from pests like termites or rodents, which can sometimes be an issue with standard wood framing.
Okay, so it's strong enough for its job, durable, gets better over time, and even protects the main structure. Let's get into construction demystified. What's actually in it, and how do you build with it?
The basic recipe is pretty simple. You've got the hemp hurds, those woody core fibers we mentioned.
Right.
Then a lime-based binder. This could be natural hydraulic lime or hydrated lime. Sometimes a little bit of cement or another binder, like a pozzolan, is added to help it set faster.
Okay, hemp-lime.
And water. That's essentially it.
And how do you turn that mix into a wall?
There are a couple of main ways. One is making precast hempcrete blocks.
Like concrete blocks, but made of hempcrete.
Exactly. You mix the materials in the right proportions, mold them into blocks. They come in various widths, maybe 6 to 30 centimeters, and then they need to cure. This usually takes about 6 to 10 weeks, often just air drying outdoors, to reach their proper strength and hardness.
Or the other way.
The other main method is casting it on-site, cast in situ, or spraying it.
Spraying hempcrete.
Yes. You mix it on the building site and either pour it into temporary forms to build up the walls layer by layer, or spray it against the structural frame, often using specialized equipment.
And that needs to dry too.
It does. Cast or sprayed hempcrete needs about 4 to 8 weeks to dry and cure sufficiently before you can apply finishes like plaster or paint.
So using the pre-made blocks could speed up the on-site building time because they're already cured.
That's the advantage, yes. No on-site curing wait time with blocks.
What's the actual installation like? Do you need highly specialized skills?
It's often described as a blend of masonry and carpentry. Laying the blocks is pretty similar to standard block work.
Okay.
For the cast in situ or sprayed methods, you need carpentry skills to build the temporary formwork. Usually that's made from OSB panels, like 34-inch thick.
Like molds for the walls.
Pretty much. You secure these form boards to the structural frame, using screws and spacers to create the right thickness for the hempcrete wall.
And then you mix and pour.
Right. Mixing is key. You want a consistent batch. Specialized mixers are recommended. The ratio is usually around 1.5 parts binder to 1 part hemp core by weight. Water quantity is also important, about 6 gallons per 50-pound bag of binder and 33 pounds of hemp.
And then you just fill the forms.
You place it in layers, maybe about 2 inches thick at a time, and tamp it down firmly. You need to be careful to get good compaction, especially near the form surfaces and around things like pipes or electrical conduit.
Ah, conduit. So wiring needs to go in first.
Absolutely. All electrical wiring needs to be run inside conduit before you place the hempcrete around it.
Good tip. Any tricks to speed things up?
For faster hand-placed installation, sometimes a double stud wall frame is used. That makes attaching the formwork directly to the studs a bit easier.
Okay, and where can you actually use hempcrete in a building? Just walls.
Oh, it's quite versatile. Exterior walls, interior walls, great for thermal and humidity control there. Roofs and floors, too, for insulation against heat and noise.
Floors.
Yeah, you can use it as insulation under flooring or even as a kind of supporting layer. It can also be used as a plastering medium itself.
Wow. New build and renovations.
Both. It's great for new construction, but also really useful for retrofitting older buildings to improve their insulation. And an interesting point, while it's mostly non-load bearing, internal hempcrete partition walls can actually add some shear strength to the building, which isn't typical for standard internal walls.
Seems like it has a lot of potential applications. Right, let's tackle the big one. Cost and scalability. For anyone thinking about this from a farming or business angle, the economics are key. What's the cost situation?
It's a really important question, and the answer is, well, it varies. For cast in situ and sprayed hempcrete, the upfront costs can be higher than conventional materials.
Why is that?
Mostly down to labor building. The formwork takes time. Specialized equipment might be needed. And depending on where you are, the materials themselves or finding experienced installers might be more expensive or harder to come by.
Okay, so potentially higher initial outlay. What about the blocks?
The precast blocks tend to be more cost competitive. Supply costs might start around, say, $105 per square meter. That aligns a bit more closely with standard material costs.
That sounds more accessible. Are there longer-term savings?
That's where hempcrete can really shine. The energy savings from its excellent insulation can be substantial over the life of the building. Lower heating and cooling bills add up.
Right.
Plus, its durability and moisture control mean potentially lower maintenance costs. Less worry about mold, dampness, and related problems.
So maybe higher upfront for some methods, but potential payback over time. What about getting the materials? Is scaling up production a challenge?
Availability is still a bit limited in some places, both for the hemp herds and the skilled labor, but it's definitely improving.
Because hemp farming is becoming legal again.
Exactly. Legalization in places like the US, Canada, India, that's boosting the supply chain. The market is growing quite fast.
Do we have figures on that?
Yeah, the global hempcrete market was estimated at nearly 26 billion US dollars in 2024. It's projected to grow at about 5% per year, reaching close to 35 billion by 2030.
That's serious growth.
It is,
Yeah.
driven by that push for sustainable construction and, as you said, more relaxed laws around growing hemp.
Are there still big hurdles then for cost and scaling up?
Yes, the initial cost difference compared to, say, basic concrete is still a barrier for some projects. And just general awareness, a lot of builders and homeowners still don't know much about hempcrete.
So education is needed.
Definitely. There's also ongoing innovation, prefab panels, different composite mixes, but scaling up industrial production and ensuring consistent performance compared to materials we've used for decades, those are still areas being worked on.
And regulations, building codes.
They vary a lot globally. Growth is strongest where hemp farming is legal and supported, like in the EU, Canada, parts of the US. But a lack of fully standardized codes everywhere can still be an obstacle.
You mentioned the residential market is leading.
Yes, residential buildings made up almost 60% of the market in 2024. People want energy-efficient homes, healthier indoor environments. That segment is expected to grow fastest, too.
But commercial is growing too.
It is. Non-residential is seeing growth, maybe around 4.3% CAGR. That's driven by green building targets for companies and governments, and also retrofitting existing buildings.
And which parts of the world are really embracing it?
North America has a big share, about 40% of revenue in 2024. Good momentum in the US and Canada with the focus on sustainability and better hemp regulations. Europe's expected to grow significantly. France, Spain, Italy are key markets. There, they have established hemp growing and a strong interest in carbon-neutral materials.
And anyone else?
Asia-Pacific is also growing, around 6% AGR projected. India, interestingly, is expected to have the highest growth rate within that region, maybe 7.4%. There's a big push for sustainable, affordable housing, though they still face challenges with hemp cultivation rules and awareness.
Fascinating to see the global picture. Let's talk
Yeah.
about the global pioneers. Who are the companies and projects really leading the way?
Well, France is definitely an early adopter. They've been using hempcrete since the 1980s, believe it or not.
Really? That long?
Yep. So they have pretty established supply chains, and it's used quite a bit in both homes and other buildings. Canada's adoption is more recent, but growing steadily.
And the U.S.
In the U.S., things really started picking up after the federal legalization of hemp in 2018. You've got companies like Hempstone LLC, Hempatecture, American Hemp specializing in it now. Though historically, the U.S. faced more supply chain issues and has built fewer hempcrete buildings compared to Europe.
Are there specific company names that people should know?
Yeah.
Leaders in the field.
Sure. Some key global players would include IsoHemp, they're based in Belgium. There's Hempcrete Natural Building Ltd, Americhanvra Cast Hemp, Lime Technology, just biofiber structural solutions. Quite a few now.
Any new players emerging?
Yeah, you see companies like Hemp Ecosystems in India focusing on affordability and sustainability. And Hempitecture in the US, they also make hempwool insulation from hemp fibers.
Is there much research happening?
Yes. For example, Americhanvra Cast Hemp recently got a research grant to do more testing and advance hempcrete construction methods.
Good to see that development. Can you give us some examples of actual buildings?
Definitely. There's the Flat House in the UK that used prefabricated hempcrete panels, which is interesting.
Quick build.
Potentially, yes. In France, they've built things like sports pavilions using hemp blocks. You see houses in Brazil, Ukraine using it for thermal insulation, sometimes even within the structural frame design.
So it's being used in diverse ways around the world. That's really encouraging. Okay, now for that exclusive bonus insight. If someone listening is really interested now, maybe wants to get hands-on experience or find a qualified builder, what's the best way to do that?
Good question. A great starting point for finding workshops is just searching online. Use terms like hemp building workshops or maybe natural building workshops for your local area. Look specifically for ones that mention hempcrete.
Okay, basic search first.
Then, check out the websites of hemp building associations. The U.S. Hemp Building Association is a good example. They often have lists or directories of certified builders, and they post upcoming training events, too.
So industry associations, makes sense.
Another route is contacting some of those established hempcrete companies directly, the pioneers we mentioned earlier. They might run their own workshops, or they'll certainly have networks of contractors they trust and could recommend.
Reach out to the experts.
Exactly. And finally, don't overlook local green building organizations or sustainability centers in your town or region. They're often plugged into the local scene and can be really valuable resources for finding workshops and professionals.
That's excellent practical advice. Thank you.
Yeah.
So wrapping up, it really seems Hempcrete offers this fascinating link between sustainable farming and greener construction.
It really does. If you're new to farming or thinking about how to diversify in an eco-friendly way, hempcrete is definitely worth investigating. The demand for sustainable building materials is only going up.
And growing hemp could potentially supply that market.
Precisely. It offers a way to potentially add value, whether by growing the raw material or even developing skills in hempcrete construction itself.
We definitely encourage you to explore the resources we talked about, maybe reach out to some experts if this has sparked your interest.
And maybe just a final thought to leave you with. How can we better connect traditional farming knowledge with these innovative, sustainable building solutions? Thinking about that intersection could really help shape a more resilient future. We hope this exploration has been valuable. Thanks for joining us on the Deep Dive.
Hitting that like button and smash that subscribe.